Okay, now we're getting into the part of section 6 where we look at the graphs of the tangent and cotangent functions. We've already looked at secant and cosecant earlier in this section, and of course sine and cosine in the previous section. So remembering that the tangent of x is defined to be the sine of x over the cosine of x, one of the quotient identities, we just look to see, first off, where do we have x-intercepts? Well, we have x-intercepts when the numerator is 0, which happens at pi over pi times k, being an element of the integers. So that would be like 0 plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, and so on. And we also have to worry about the variable in the denominator. Can we get 0 in the denominator? Well, the cosine of x is 0 when x is pi over 2 plus pi k. So it'd be like plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, and so on. Now, unlike the other four trig functions, tangent and cotangent have a period of pi. So you can see that I have created a table of some key values to get an idea of what the pattern looks like. Because this is a periodic function, the graph is going to be the same pattern for each period of space here on the x-axis. Also remember that tangent, which is sine over cosine, is an odd function. So we're going to have symmetry to the origin. Now I'm going to graph these key values here, and then I'm going to use that pattern to graph the rest of it, and then we'll look at cotangent. So first things first, let's get some vertical asymptotes going here. So I have vertical asymptotes at pi over 2, so I'm going to try to do my best to freehand this. Don't you freehand it. You get a ruler, straight edge of some type, and you draw it nice and neat and dotted with arrows on the ends. And I'm trying to do so right now, although I'm not doing great. And that's what happens when you want to try to keep your videos relatively short so that you don't get too bored with my voice. So I have these as my horizontal asymptotes, at least on this part of the graph that I have. Now I have picked x values that are in this space here, in this interval between these two vertical asymptotes. I'm going to graph those, and then I'm going to try to draw a smooth curve to reflect this. Now remember, that the square root of 3 is about 1.732. So the square root of 3 divided by 3 would be about 0.6. Well, this is going to be negative 1.732, so I'll graph this here at negative pi over 3, which would be about here, down to about here. I'll put a point, and then at negative pi over 4, which would be right here, I'm at negative 1. At negative pi over 6, I'd be at about 0.6. I'm going to approximate it. And you say, well, gee, that's not very much. Well, you'll see the curve here best I can in just a second. You're going to have to graph a heck of a lot more points to get a real clear vision of it, but I'm going to help you. If I plug in 0, I get 0. If I plug in pi over 6, I get the 0.6. And then pi over 4, I get 1. And then at pi over 3, I get the square root of 3, which is about 1.7, give or take. And it almost looks like it's a line, but it's certainly not a line. What happens is, remember, these are asymptotes here. Your graph is going to kind of approach the asymptote the closer your x value gets to negative pi over 2 from the right or pi over 2 from the left. And so you get a graph, remember it's symmetric to the origin, that does something like this. Okay, there's no little wave in there, but that is enough of a graph that you can just repeat this here, here, and all the way through on both sides. That's the basic shape. When we get to inverse trig functions, which is not that far away, we'll be looking just at this piece of the graph. for the inverse tangent, but that's a little bit of a spoiler there. Sorry about that. So I'm going to continue this. And hopefully not mess it up too badly. Take your time with this and do a good job. Kind of going like this. Now, that's the graph of the tangent. It's quite a bit different than the graphs that you've seen before with the sine and the cosine, where you had the wave and the cosecant and the secant, when you had the what appeared to be U-shaped pieces that are opening upward or downward. You get these kind of elongated curves here, but again, you have the asymptotes to help guide you. Not all that different would be for the cotangent of x. Now remember that the cotangent of x is defined as the cosine of x over the sine of x, also another quotient identity. And of course, if we're looking for x-intercepts, we want to know when the numerator, which is the cosine of x, is equal to 0. Well, we looked at that back here when we were looking at vertical asymptotes, pi over 2 plus pi k, k an element of the integers, and the vertical asymptotes, when the denominator is 0, which is what we're looking back here, then it happens at multiples of pi, pi k, where k is an element of the integers. The period also is pi, but it's an even function. It's symmetric to the y-axis. So what I'm going to do is kind of what I did here. I'm going to put in my vertical asymptotes, and then I'm going to graph the points that I went ahead and already created this table of values here. So I have a vertical asymptote at all the multiples of pi. So I have one here at negative pi. Oops. I have one at 0, that's a multiple of pi. I have one here at pi. Oop. And one at 2 pi here. Hopefully this isn't too bad. That one looks like it's got a little wave to it. There we go. And we have our different regions here. So now I'm going to graph these points. And again, notice the y values. Same as these y values, in a slightly different order, but the same as those y values. So I'm going to graph those. I'll start by well, of course, that's where the vertical asymptote is at x equals 0. But at pi over 6, I'm at the square root of 3, which is about 1.7. So that'd be about here. At pi over 4, I'm at 1. At pi over 3, I'm at, remember, this is about 0.6. At pi over 2, I'm at 0. And then I get the negative values. At 2 pi over 3, I'm at about negative 0.6. Let's see about here. And then I'm at negative 1 at 3 pi over 4. And at 5 pi over 6, I'm at negative 1.7. Let's see, about here. And it's not in the same exact direction as this, but it's the same kind of a curve. It's almost as if it was reflected. The graph kind of goes, instead of kind of going up and to the right and down and to the left, it goes up and to the left. And again, use your asymptotes. And down and to the right for each one of these pieces of the graph. And then I just continue that pattern as I continue to go here. So let's see, I'll try to do my best to kind of freehand it. Unfortunately, without points graphed, it's kind of guesswork to a certain amount. That's why you should always try to plot points whenever possible, especially when the directions are asking you to graph, not copy a graph from decimals. And so on and so on and so on. So those are the graphs of the tangent and the cotangent. We'll look quickly at maybe some transformations that are involved in here, but I think everybody needs to see all 6 graphs of the trig functions, graph the parent graphs, and then of course the transformations come along with that. But you need to see it at least once in your high school or college math career, and hopefully this is helping you out.